Hello! Alright, so the purpose of this video is to basically give you a brief introduction into logarithms. Okay, so before we get into logarithms, first I'm gonna do is I'm going to start off with something you guys are familiar with. So y equals 2 raised to the power of x. So this is an example of an exponential function. Okay, so remember this exponential function, and this right here would represent exponential growth, okay, because this number here is greater than 1. Okay, let's go ahead and plot particular points that fall on this graph. Okay, so for example, well, when x is 1, right, so 2 raised to the first power is going to be 2. Okay? If I plug in 2 for x, 2 raised to the second power is going to be 2 times 2, and that is 4. Okay, and then 2 raised to the third power is going to be 8. Okay, so 2 times 2 times 2 is 8. So these are just some points that fall on this particular exponential function, right? So another thing that I also want to show you guys is I'm also going to graph this diagonal line. Okay, so I'm going to graph the diagonal line y equals x. So recall that right there, yeah, that's a diagonal line. So let's say what we want to do is we wanted to find the inverse of this particular function. Okay, so more specifically, what we can do is, you see these points here? We could go ahead and find the inverse of those points. And basically one way we can do that is, if you guys, I don't know if you guys remember this, but we can swap the x and y values. So if we swap the x and y values, we get 2, 1. The next one becomes 4, 2. And the next one becomes 8, 3. Okay, so we're starting to create another part of the graph here as well. Okay, so the reason why I'm trying to make you guys understand this before I go into logarithms is because basically an exponential function's inverse is a logarithmic function, and vice versa. So basically a logarithmic function's inverse is going to be an exponential function. So what I mean by that is I'm going to type some other notation here to help you guys out with this. So I have y equals, what I'm going to do is I'm going to write log with a 2 and an x. Okay, so basically what this says here is this is the logarithm with base 2 of x. Or in other words, a shortened version, we just say log base 2 of x. Okay, so as you can see here, it kind of stems from this exponential function. So the inverse of this exponential function is going to be a logarithmic function, right? Now let's go ahead and consider one of the particular points on this logarithmic function. So let's go ahead and take this point here, 8, 3. Okay, so basically I'm just going to put on the bottom here. So this says for this logarithmic function in black here, this says log base 2, and if x is 8, that's going to equal 3. So I'm going to type this in here so you guys can see this, log base 2 of x. So instead of x, we're going to put an 8 in here. And as you can see here, it's equal to 3. Okay, so as we saw earlier, so you know, up here, if I plug in 3 into here, so let's create another line here. So this is, so let's say we have 2 raised to the third power. So we have 2 raised to the third power is going to be 8. Okay, so let's look at each of these specifically. Okay, so basically what this means is, in its simplest form, a logarithm here, so logarithm is equal to an exponent. So just keep that in mind. Logarithm is an exponent. Okay. And the reason why we can see that there is because this is 3. So this is the exponent here that I'm talking about. Okay. Right. So let's go ahead and look at a few examples involving logarithms. Alright, so let's go ahead and look at some examples. Okay, so let's say we want to evaluate the following expressions here. Okay, so we have 3 different expressions as shown here. Okay, so let's say we want to figure out what log base 10 of 10,000 is. Okay, so just to help you guys out with some terminology, this here represents the base, and what this base is referring to. So for example, let's say I have an exponential function, so like a base raised to some power, so we'll call it b, so this is our base, and we're raising it to some power y. That's going to be an exponent. Okay, so I'm going to write this out for you just to kind of help you out with what this means. Okay, so basically, in order to evaluate what this is, okay, so this basically says, so what exponent, okay, so what exponent are we raising the base of 10? Okay, what exponent are we raising the base of 10 by to get 10,000? Okay, so I'm going to write this out for you guys. Okay, so in the context of what we have here, what exponent, I'm going to call it some exponent y, are we raising the base of 10 by to get 10,000? Okay, so this comes a little number sense exercise. Well, what power could this be to be 10,000? And actually, if you do it correctly, I believe that would be 4. So this is y in this case equal to 4, because 10 times 10 times 10 times 10 is going to be 10,000. Okay, so basically what this implies here, so again, a logarithm is an exponent. So we have log base 10 of 10,000 equals 4. Okay, that's basically how we would evaluate that. Okay, so this next one, letter B here, so same idea. Okay, so we start off with, so what exponent, so we'll call it y, are we raising the base of 3 by this time? So what exponent are we raising the base of 3 by to get 9? Okay, so let's just think about that. Well, 3 times 3 in this case is going to be 9. So this says y is going to equal 2. So in other words, what we have here, if we're to evaluate this, this says log base 3 of 9 equals 2. Okay, so again, what I mentioned earlier, just think of it as a logarithm is an exponent. Okay, so let's look at this last one. So same idea, what exponent, y, are we raising the base of 4 by to get 1024? Okay, so if you do it on a calculator, it gets 4 times 4 times 4 times 4 times 4, and if you do that, you're going to get 1024. So this is y is equal to 5. So in other words, what we have here, so this says log base 4 of 1024 is going to equal 5. Okay, so these are just some general examples first, before we dive into a more deeper content. Okay, now let's go ahead and explore this a little bit more. All right. Okay, so basically what I showed you earlier. So if we have x here is a positive number, then the logarithm of x to the base b, denoted log base b of x, is the number y in this case. Okay, so like I showed you guys earlier, so such that we said the logarithm is seen as an exponent of an exponential function, for example. So it's just such that we have b raised to the y equals x. That is basically these two are similar. Okay, so what I also want to show you is, recall earlier when we did this in decimals, right? So this says we have log base 2 of 8 equals 3. Let's go ahead and write that there. Okay, so this is log base 2 of 8 equals 3. Okay, so basically what this says is, you know, this thing, if you just flip it around, this is log base b of x equals y. Okay, so let's go ahead and I'll go ahead and just actually help you guys out with in order to write this as an exponential function. Okay, so a little just a little trick. Actually, I'll credit Mr. Cam for this one. So this is something I didn't learn when I was in high school, but I give him credit for this. All right. So for logarithms, one way to kind of remember this is this number here is our base. So I'll write it. This is our base, right? This here is our answer. Okay. This last number here is our exponent. Okay. So if you look at what this spells, I know some of you high school like these kinds of things. Look at this. It spells bay. So that's one way to remember logarithm. It spells bay, right? So bay in this case, so you have base, so your base is 2, exponent is 3, and your answer comes after. And there we go. So that's another way that you can visualize this. Okay, so let's go ahead and do some more examples. All right, so let's go ahead and look at some examples. Okay, so we want to rewrite each of the given logarithmic equations in exponential form. Okay, so we can use that little trick that I showed you earlier. So one way you can do this, you can identify the base, the answer, and the exponent. So this is our base. This is our answer. This is our exponent. Okay, so what we have here, if we write the base, well, the base is 5. Our exponent is y. Our answer is 125. Okay, and that's it. Okay, so let's look at this one. We need to identify our base. Then we need to identify our answer. And then we need to identify the exponent. Okay, so this is 7 raised to the power of y equals 49. Okay, let's keep going. This is our base. This is our answer. This is our exponent. Okay, base is 15, raising it to the power of y. Our answer is 1. Okay, let's keep going. This spells bay, base, answer, exponent. Okay, so 2 raised to the y equals 1 over 16. That's it. Okay, this one, so this is our base, this is our answer, and this is our exponent. Okay, 6 raised to the y equals 1 over 36. Okay, this is our base, this is our answer, this is our exponent. 8 raised to the y equals 1 over 8. Okay, and that's basically all there is to that one. Okay, so let's go ahead and look at more examples now. All right, so let's look at another type of example here. Okay, so here's another formula you could use, a base with a logarithmic power rule. Okay, so you'll see here pretty soon how this can be applied. Okay, but anyway, so let's start off with this. So it says given the logarithmic equations here, our goal is we want to solve for x. Okay, so I'm going to show you 2 different ways to do it. Okay, I'm going to show you Mr. Cam's method, basically the way that he does it, and I'll show you the way that I do it. Okay, just a matter of preference what you decide to do. Okay, so using Mr. Cam's method, so what we can do with this is same idea. So this is our base, this is our answer, and this is our exponent. So as you can see here, you'd write it, well, this is our base, our exponent is 4, then we write our answer here. Okay, so 2 raised to the 4th power equals x. Well, we know that 2 raised to the 4th power is going to be 16. So this says x is equal to 16. Okay, now what I'm going to do is I'm going to show you the way that I do it. Okay, so the way that I do it, so we have log base 2 of x equals 4. Okay, so the way that I like to do it is I actually use this formula here. And that actually helps with the other formula, because I remember when I actually learned this in high school, I had a very hard time wrapping my head around the formula, like what goes where. Okay, so logically, another way that you could do this is you can rewrite both sides of the equation here with a certain base. So you just look at this base here. Okay, so let's say we want to rewrite both sides of this equation with the base of 2. Okay, so this is 2, and then we have log base 2 of x equals 2 raised to the 4th power. So basically what we're doing is we're just putting a 2 underneath there. Okay, so what we have here, as you can see here, so this expression says that this is equal to x. So what we're left with is this is x equals 2 raised to the 4th. And by doing this method, you actually don't have to really memorize any formulas. You can just kind of just logically solve it. And this would be x equals 16. Okay, so that's basically how that one works. Okay, let's go ahead and I show you another example. Okay, so let's do letter B here. Okay, so what we have, again, so you can do Mr. Count method if you want. This is our base, this is our answer, this is our exponent. Okay, so what this says is this is 3 raised to the negative 6 equals x. Okay, base, exponent, and then answer. Okay, so this says here, this is x equals, so this is 1 over 3 raised to 6. Remember, we used that formula. It looks something like a raised to negative m, so that's 1 over a raised to m. So basically, as you can see here, basically we're putting that in the denominator. So that's 1 over 3 raised to 6. Okay, so that's, I'm just going to leave it in that form, 3 raised to 6. You can actually, that's 3 times 3 times 3 times 3 times 3 times 3. I'm just going to leave it in that form just to keep it simple. Okay. So another way that you could do it, so you could also use the method that I like to use. So we have log base 3 of x equals negative 6. So the way I like to do it is, well, I see my base right here. This is my base. We're going to rewrite this here with a base of 3 on both sides. Okay, so this expression is equal to x. So x equals 3 raised to negative 6. And that's the same thing as 1 over 3 raised to 6. Okay, so however you want to do it is entirely up to you. Okay, so let's go ahead and look at more examples. All right, more examples. Okay, so this one, this is our base, this is our answer, this is our exponent. 7 raised to the 5th power, base, exponent, answer. Okay, so this says x equals 7 raised to the 5th. Okay, or you can do the method that I like to do. If you have log base 7 of x equals 5, as you can see here, our base is 7. So we're going to rewrite both sides of the equation with the base of 7. And as you can see here, this is the same thing as x. So x equals 7 raised to the 5th. Okay. Now let's go ahead and look at this one. So again, this is our base, this is our answer, and this is our exponent. Okay, so what we have here, base is 23. 23. Our exponent is 0, and x is our answer, so it's going to be x. So what we have here, if you simplify this, so anything raised to 0 power is 1. So basically this is x is equal to 1. Okay, or what you could do, kind of like what I showed you guys earlier, so have log base 23 of x equals 0. So the method that I like to do is, well, look at our base here. You got to rewrite both sides of of the equation with a base of 23. Okay? And this left-hand side just becomes x. So x equals 23 raised to 0, and that's x equals 1. Okay? All right, so letter E, this is our base, this is our answer, and this is our exponent. Okay, so this is 8 raised to the first power equals x. Okay, so in other words, we have x equals 8. Right? Now, what we have here, so log base 8 of x equals 1. So, same idea. So, as you can see, our base is 8. So, what we're going to do is we're going to rewrite both sides of the equation with the base of 8. This expression is the same thing as x. X equals 8 raised to the first power, and x is equal to 8. Okay? Letter F. This is our base. This is our answer. This is our exponent. Okay, so what we have is 4 raised to negative 3 equals x. Okay, so flip this around, x equals, so actually 4 raised to negative 3 is the same thing as 1 over 4 cubed. So if you guys remember that with negative exponents, so this is the same thing as 1 over 4 cubed. And 4 times 4 times 4, well, this is 1 over 64. Okay, so that's how that one works. Okay, and now, let's say we do this again, log base 4 of x equals negative 3. So again, same idea. We can rewrite both sides of the equation with the base of 4. This expression on the left is the same thing as x. So we have x equals 4 raised to negative 3. And like I showed you guys earlier, well, this is the same thing as this. So this is basically 1 over 64. Yep. So how you want to do it is entirely up to you. Okay. And that's basically it for this video. Okay. Please let me know if you have any questions.